Do you know how to use the Python code for VLSI EDA automation? Do you know how to execute various operating system command line features through Python code? Do you know how to do the globbing operation using Python? Let's start our journey to know all the answers. Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will talk about the OS module and various example of this module as a Python code which is used for tool automation in VLSI. Next, we will talk about various types of dealings with the operating system. The basic operations we'll cover here through Python code example. Next, we will talk about the methods to convert a relative path into an absolute path and extract file name. This can be very essential when you are dealing in a shared network drive area while you are working in a VLSI company. Next, we will talk about the common path and prefix extraction from a group of paths. Generally, this group of paths can be received from a environment variable while doing the automation for your VLSI tools through Python. Next, checking of a file or path whether it exists or not. That means the given path, whether it is an absolute path, whether it is a relative path, we will use a Python code that will ensure that whether that particular file or path does exist or not. Next, we will talk about globbing. Now, globbing is nothing but the kind of find a particular file type, say txt, inside a particular directory or inside a particular path. So globbing is that thing. We will use Python code to do the globbing. Next, we will do the file name matching so that you can match a required file name in a given path. Next, in the last slide, we will talk what is the equivalent of Perl's chomp in Python. Perl's chomp actually trims out the trailing whitespace characters of a particular string. Generally, this is very useful when we are dealing with any file name to remove the trailing whitespace character, whether it is \n, \r, whatever. So removing that, we will talk about the methods in Python, the methods available in Python to do the Perl's chomp kind of equivalent work. So in a nutshell, we will do today's episode through different Python codes serving our purpose in the way of VLSI EDA automation. So that's the menu for today. Without any further delay, let's begin. OS module, tool for automation. In this slide, we will talk about the introduction of OS module to you, and this module and its various components can be used for the VLSI EDA automation. The OS module, the command we will use, the import OS, provides a portable way to use operating system dependent functionality. That means whatever operating system related commands are there, you can execute them through Python. OS specific extension available in OS module but may impact portability across different OS. That means once you develop the code maybe for Linux, it may not be portable to the Windows. That means whatever code you are writing for Linux, that cannot be ported into Windows, and vice versa. That means even if you are doing a code for Mac OS, you cannot port it into the Linux. That means whatever OS you are in and where you are coding, your codes will be very much specific to that particular OS. And it's not a global code, it's a local code with respect to the operating system you are working on. This thing you have to remember, because previous all codes, whatever we have discussed in series, is almost portable across different OS. But this OS module and its components, whatever we are using, will be particularly to a specific operating system. And here in VLSI, the background OS is either Linux or Unix, so we will code according to that in our today's episode. We can use the os.path for path related operations and manipulations. We can use file input to read lines from command line files. we can use temp file for creating temporary files and directories. So this is a very important factor, because when we are doing the EDA automation, right, we have to keep something in our mind that for a while we need to work on some temporary files, and that temporary files and directories we can create through our OS module. And once our work is done, we can delete those temp file or directories. OS module functions accept both bytes and string objects for path or file names. Next, OS module functions in the module raise OS error for invalid or inaccessible file names, paths or unsupported arguments. That means when you are using a file path or file name, if there is something invalid, that means it doesn't exist or something like that, we will get a respective error, and our OS module is well equipped with that. So that's the short and sweet introduction to the OS module, what it can do and what it cannot do, and what are the options. In today's episode, we'll talk about some of these options through Python code, and we are using Python 3. So we are done here in this particular slide. Let's move on to the next slide. Dealing with operating system. Here goes the first line of our hashbang user bin Python 3. This is our Python interpreter, and remember, we are working only and only in Linux as we are talking about the EDA automation in VLSI. So we will restrict our code, at least in this episode, for Linux operating system or Unix operating system. Next, we use the most important command, that is import OS. We are importing the OS module from the Python library. Next, we write the variable pwd is equal to os.getCwd. You remember that in Linux we have a command pwd, and hence we have named our variable as pwd, and we are calling the method getCwd from the OS module. That means get current working directory, and the result will be stored in this particular variable. In the next line, we do the print operation of this pwd. Next, we are using the os.system command, and whatever we write in this bracket will be treated as a Linux or Unix command, and accordingly that we will get an output. So in case you do not have a pre-listed method or function like getCwd, you can go ahead, use the os.system and then use your known Linux command here to get a desirable output. We use the rate variable here, and next we will print it. So here we print our rate variable to get whatever we get as a ls command in our present working directory. So first we do the print of the present working directory. Next we do a ls in our present working directory. Next is the most important function that can list whatever things are there in the entire module. So this is not only for this particular OS module. This command can be used with any of the modules that you can import. First, here rate is equal to dir then OS. So dir command will list all the modules that are available in this particular OS module. Here we are talking about OS module, and hence we are giving OS. In case we are using some other module here, we can use it here. And next we print rate. And once we run this code, we get the below output. So first one, when we do the print pwd, we get this. So this is our first output. And this was inside the my documents, and then we have a Python tutorial and then Python test. This folder we are writing the code, so it gives the directory, the full path to this particular directory or folder. Next, as we do the os.system then ls and we print here, we get all these files. That means all these files. So here you can see all of the Python files are there. So these Python files are nothing but the codes that we are going through this particular tutorial, and whenever I am writing any code, I am trying it out and then I am putting it into the PPT so that I can present the code to you, and the directory contains all the codes that has been written by me whatsoever, and those names will be printed as by the ls command. Next, we give the dir.os command, and here you can see that all the methods here are printed which are available in OS. However, this was a very long list, and I have just truncated it so that you can get a quick view. But however, it was very long list. However, I have truncated it so that you can get a quick view of the things that are available in the OS module. But don't worry, the most important things in the OS module we will cover through examples in this episode and the next episode. So here we are done with this particular particular slide, let's move on to the next slide. Here we will do a relative to absolute path conversion and the file name extraction through Python code. First, here is the first line of the code, that is #bang user bin Python 3, as we are using the Python 3 interpreter and the Python 3 coding. Next, we write import OS. Next, we write a relative path, and here we have created a file with some text in the file.txt, which is one directory above, just above our present working directory, and hence we are giving within single quotes the file.txt, and above that we are writing // means we go one directory above and there is a file.txt. With our knowledge we are creating this file. However, when you are working in actual VLSI EDA automation, you will get this particular file maybe as a sum tool output, or maybe from a log file, or maybe some tool output file. Next, we will convert this apps into absolute path. This relative path we will convert now into the absolute path. For that, we write the command absolute path is the variable, and here we write os.path, then abs path. So we have OS module, inside that we have path. I have just described in the introductory slide, right? We will use the OS path, and here we will use the abs path method or function to convert this relative path. This value goes here, and this abs path method will convert it into the absolute path, and then we print the absolute path as the print command. So we give the print relative path and the relative path, and then we print the absolute path and then absolute path, so that we can compare the relative and the absolute path side by side. Next, to get the base file name of the file, so we have a file name and we will get the base name. We write the command here starting with a variable. The file underscore name is os.path. Again, you can see os.path is again used, and the method is here the base name, and then we give the relative path. Relative path means this content will go here, and we have the file name is file.txt. So we want to get that particular name, and then we print the file name, that is from relative is file name. And here again we use the same variable, as we do not want to use another variable. We done it like that, and we get the OS path name, then base name, and we give the absolute path. Absolute path is from here, we get it, and in this case it must show also the same, that is the file.txt. There is another print command here as the absolute path, and from there the extracted file name. So once we execute this particular code, we get the below output. First, you can see the relative path here, the file.txt. This is the relative path as we have written here. Next, we get the absolute path using this abs path, and using this particular variable, it comes here as absolute path, and you can see that the whole path is stretched in long format. Next, we have the relative extraction, that means the file name extraction from the relative path is file.txt, and we do the same for the absolute path. That means from this path and this path we have extracted the file name, and since this is same, we are getting the same output in both the cases. So we are done with this particular code. You can download the code from the GitHub link. The link is provided in the description. You can go ahead, you can do some modifications, and you can try out at your end. We are done here with this particular slide. Let's move on to the next slide. Common path and prefix extraction. So here we will do the finding out of common path. That means we have several paths, and we will find the path that is common in all of them, and here we can extract the prefix. So here goes our code. The first line is our Python interpreter, that is #bang user bin Python. Next, we use the import OS command. This is the most important, don't forget to write it. Next, we have paths. There is a list, right? And here we manually give the paths, right? Here the first one is there, second one is there, and third one is there, and we close the list here. So these are the files, and you can see here we have something common here in all of them, and we want to extract that, right? For that, what we have to do here, let's get the common path and prefix along the given paths. We give a variable name common underscore path, and we can write the OS path and then the common path method or function to extract the common path. That means this one up to the documents, right? Here we give the list of the paths. Next, we write another variable common prefix. Prefix means it may be a path or it may not be a path. However, whatever up to which this is common, whatever string there is common among all these paths, that will be extracted by this method, the common prefix, from the os.path. And here we also give the list of the paths. Now let us print the common path and common prefix. We write print common path, then common path. This is the common path variable. And we use the print common prefix and we give the common prefix. Once we run this particular code, we get the below output. As we all know that common path is up to home, user, then documents, and then the common prefix is up to documents and then F. So you can see there is a slight difference. The common path is up to this and the common prefix is up to this. So we are done here in this particular slide. Let's move on to the next slide. Here in this slide, we will talk about checking whether a file or path does exist or not in the physical disk. In VLSI automation, this might happen that you get a file path, maybe from an output log file, maybe from some other tools output, or maybe somewhere else in the entire chain of the automation. But you want to check whether that particular path or file exists before you want to pass it on to the next automation step. It may be a tool or it may be some processing using your Python code. For that checking, what you will use. So let's start our code. The first line is hashbang user bin Python 3, our interpreter. Next, we do the import OS. Next, we write the path is equal to file.txt and we have a // before it. That means it's a relative path. In previous example, we have used this. That means we know that this file exists. But in real case, this you have to be certain by using the next line of codes. If os.path then L exists, then the path, that means if this path exists or the file name exists, we will print the path and the file name. Here we are using the F. We'll shortly talk about this F. Next, in the else part, we have that it does not exist. So if it is untrue, that the checking is untrue, that means this file do not exist in the disk, we will print a different message. So this way we can take a decision whether we will pass on the file name or path to the next step of automation in Python or not. Here, let me talk about the F. The print with F statement in the code is provided as an example of the F string. This requires Python 3.6 at least. That means we are using Python 3 and we said that in the beginning of the series that we are using Python 3.8 or Python 3.10, or you may use any version above. But to use the print with F, you must have at least Python 3.6 in your system. Next, an F string is short for the formatted string literals, allows you to embed expression directly inside the string by using the curly braces. So here the path, right? This is the path and you can extend it inside the basic print operation. Once we run this code, we get the below output. The path and then we get the path and the file name here as a print exist. That means we know this file was there as per our previous experiences in the previous slide, and we have reached this one, the true condition. So in case we are reaching to the else, in a real case, we will issue some warning or error that the file doesn't exist. So we are done here. You can download the code from the GitHub link provided in the description and you can do some modification as per your own trial and run the code. We're done here with this particular slide. Let's move on to the next slide. Glob-ing. Glob-ing is something that we give a path and there we check some sort of file extensions are there or not. So for that, start our code here. It's a very short code. First we have our interpreter and then we write the import glob. So this is not import OS, this is import glob. Glob is another module and it has a very simple use. Like this, we get a variable ret. Inside that we use glob.glob and then we give // means present directory. We give star wildcard and .py means how many Python files are there, and then we print the content of the ret, and as we execute the code we get the below output. So there are several Python codes that are being tried before they are put into our slide. So all those Python file names are found out by this globbing. So you can download this code from GitHub link provided in the description and you can do trials as per your own and get your desired output. We're done here. Let's move on to the next slide. file name matching. In EDA automation, you have to multiple times check whether a particular type or style of nomenclature is maintained. Generally, this is for that you can use there. Let us start the simple code. First line is our interpreter hashbang user bin Python 3. Next, we have the import matching module from fnmatch. It's another module rather than OS. It's fnmatch. We import the fnmatch. From fnmatch, we import the fnmatch. That is, fn is file name matching. Next, we have a variable rate and we have fnmatch, and then we write hello.py and star.py. Okay, and we print rate. Next, we write hello, then fnmatch hello.py, then star.doc. So here we are matching whether these two are matching and where these two are matching, and then we do the print rate. Once we execute the entire code, first one, this one gives true because we have the same extension pi here, and here the second one gives false as pi doesn't matches with the doc. So this is the fn matching, and you know already about the regular expressions from the last episode. You can use the regular expressions also, but there is a module fn match. You must get aware of it, and this is the use of it. So you can go ahead and download this code from GitHub link provided in the description, and you can do some alterations in this code and try out at your end. So you're done here. Let's move on to the next slide. Now, here in this slide, we will talk about what is Python's equivalent to Perl's chomp. Now, Perl's chomps, whoever done our Perl course in our playlist, you can find it. There, we have talked about the chomp function, and it is very widely used. So, those engineers who are learning Python after Perl can relate this question, and this might be a very good question in the Python interview too. So, what is the answer of this? First, you can use s.rstrip. S is nothing but your string variable, and then rstrip, and then we use the carriage return and the new line characters to remove all the occurrences of any line terminator from the end of the string s without removing the trailing white space. Next, if the string s represents more than one line with several empty lines in the end, the line terminators for all blank lines will be removed. Next, since this is typically only desired when the reading text one line at a time using the s.rstrip, this works well. So you can use simple version, the s_string.rstrip, and in case you need a wider version, this is there. So now you have the answer to the interview question, what is Python's equivalent to the Perl's chomp? So generally, why we are talking about this Perl's chomp and its equivalent in this episode? Because generally this is used while we are getting the file and path name, maybe from a log file, maybe from our some other tool output, and like that, where there may be a chance of having some extra carriage return or new line character at the end. There you have to use it. And in Python automation, when you are dealing with the OS module, you may have some interactions like that. In that case, you can use either this or this as the Perl's chomp's equivalent. So you can use this or this as the Perl's chomp's equivalent in Python. So here we are done. Let's move on to the next slide. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in words in the comment section down below. And bye for today.